Okay, so hi, my name is Delia. I am a student TA this semester, and I'm going to be starting the first session on the SQL hands-on, interactive session. The person who was supposed to teach today unfortunately couldn't make it, so I'm here on short notice. So if there are any questions that I can't answer, we have Professor Zhang, who will come around with a microphone. We can all discuss it. And also, Luca will be monitoring the Zoom chat if you guys have any questions there. And yeah, so if you go onto the course website, you can see that we have 2 links here so that you guys can follow the session. I'll be doing it on my laptop, like on a local installation, but you guys can follow on Katacoda. So if you guys start the session, we really encourage you to be interactive, so I'll be asking you questions. Any questions that you have, please participate. And we encourage that you also run the tutorial yourselves. The other link on the website is to a GitHub repo that contains the same queries that we're going to be running. And yeah. So if you don't want to use Katacoda, you guys can also use them yourselves. So we just have to first install Postgres. You can click on these links to kind of wait until everything downloads. Yeah, it's kind of taking a while. There. Okay, this is really strange. Okay, I don't know what's going on. I think my computer's being a bit weird, but if you go through and follow all of these different steps, you guys will get to exactly the place where you need to be, where you guys can start running queries, and you can follow as I also run these queries on my laptop. Yes, cool. So we'll start the session, I guess. So the first thing that we want to do is create a table. So the table I'll be creating is called employees. Every employee has an employee number that isn't null, then a birth date, then a first name of type varchar, which means that it could have length up to 14 characters. Similarly, last name, a gender, who has a default character that is a question mark, hire date, which is of type date, that's a special type. And we're going to name the primary key to be the employee number. So what we can do is you can type \DT, and now we can see that we have the table that we just created. So can anybody tell me how we can query the contents of this table? Anyone at all? Okay, yes? Yes, that's exactly right. So if we do this, then we can see all of the attributes in our table. Obviously, the table is now empty since we haven't inserted anything into it. So would anybody know how to insert something into a table? Okay, so we are going to start creating. So we are going to use this syntax, insert into employees, values, and we're going to start with Professor Zhang. I don't know if this data is correct about hire date and birth date, but disclaimer. So that now inserts our first tuple into our table. Another way that we can insert into a table is to use this syntax where you list all of the attributes before you enter the data. There you go. Also, you can, I'm just going to add a couple more. Choose only specific attributes to insert, but we'll talk more about that later. Obviously, you can only not insert attributes that can be null in the table. So those that are declared as not null, obviously you must insert them or we get an error. So there you go. Now we can see all of the tuples that we've inserted into our relation. So does anybody know how to delete or update a table? Okay, so something that we can do is we can delete, you can write this syntax, delete from, name of the table, and then the condition, so what it is that we're trying to delete. And in this case, we want to delete where the employee number is equal to 3. So we do that. And now we can see that our table contains only the 2 tuples that we didn't delete. Similarly, we can also update a table. I'll just change this really quickly. Where now, when we run through, we can see that we've updated in the employee table where employee number was equal to 2. We've set employee number to 102. So you can put the condition here on what you're trying to update. So exactly. Cool. So now we want to look at what can go wrong and different constraints that we have when inserting tuples into tables. So the first thing that is a problem is if we were to update a table with the exact same, or insert into the table a relation that violates the primary key constraint. So if we were to insert a table, let's say, that has the same employee number, which we had previously declared as our primary key, I don't know. Oh, sorry, I've made a mistake here. we can see, okay, I've made another mistake. Oh, okay. I've assumed that there were too many columns. So you can see that exactly when I declare these tuples, I, for an example, could not just put in birth date because I haven't declared it with this syntax. Okay, this is a little bit annoying. Cool. There you go. You can also see that this is obviously not a mistake I made on purpose, but we had declared in our table that gender could only be one character, but this white space also counts as a second character, so it violates that constraint. Here, we can see that this was the primary key constraint violation that I was talking about. We cannot insert into a table where we violate the primary key constraint, even if the other attributes of the table are different. Conversely, if the employee number, we were to change this to 103, but we kept all of the other attributes in the table exactly the same, so also said Gustavo, Alonso, male, etc., it would still violate the primary key constraint. So some other problems that we may come across are type constraints. So if we were to insert into the table, for an example, instead of an int, a string, this would be the wrong type in this situation, and so it is a type constraint that we have. Another interesting type constraint to look at is if we were to, for an example, put this string, hello, where the date is. What do you guys think? Do you think that's possible? Not? Anyone? Well, it will be wrong, as you could have guessed. Another one we already came across, which was where we had a constraint on the length of char, that it could only have one character, but we had two, so that's something that you should also look out for. So there are some nullability constraints that we can look at. So if we were to insert into employees, what do you guys think will happen? Anybody? So this actually will work, and the reason why is because our date, we said, could be null, and so it's fine if we enter null and it does not violate the schema. If we were to, for an example, do something like this, what do you guys think will happen? Yes?
It wouldn't work since this value cannot be null.
Exactly. So you guys have to be careful when coding of like what can be null and what cannot be null. So there are some special, I guess, syntax constraints, you could call them. If I were to insert into employees, Does anybody know what will happen? I briefly mentioned this before, so. So we can't do this because the database system doesn't know anymore what field belongs to which field. And so if you don't want to write in a certain field, you should just write null. And if there were fields that you did not want, or you wanted to leave particular fields blank, then you should use this entry specification syntax, the one that I had mentioned earlier, where you mention exactly what you want to insert. And in this situation, if we were to enter a person named John Richards, does anybody know what's going to happen when we leave out birth date and gender? Will this query run, or will there be an error? Yes?
It will insert, I think, nil values.
Yes, and for birthday and for gender? So remember, for gender, we said that it could not be null, but its default character would be a question mark. So when we run this and we look, we can see that, yes, this tuple, we were able to enter it, and birthday had the value null, and gender had the default character. And so in columns that are marked as default, unspecified columns become the default character, and in columns marked as null, unspecified columns become null. And what happens if we were to, for an example, insert okay. We were to get rid of first name and insert something for the rest of it. It's not going to work. So, does anybody know what happens in this situation if we do not specify a column that is marked as non-nullable? Yes?
Well, it violates this constraint, so it doesn't work.
Exactly. So one thing that you can do, if you, for an example, don't want to specify the name of an employee, is to use an empty string. So then what happens is when, oh, sorry. What happens is in our table, it doesn't include that value. So that's one way that you can get around it if you really don't want to include a value for whatever reason. So one question is so this like entry specification syntax, does anybody, even though it is a lot more cumbersome, I guess, to always mention what relations that you want to add, Does anybody have an idea as to why it would be more useful to include this than to leave it out? Yes? Exactly. Exactly. So the syntax, it allows the queries to survive changes to the schema. Cool. So we've now looked at constraints on types, constraints on the primary key, nullability constraints, and one thing that I just quickly wanted to mention is that Sql is case insensitive, meaning this is the same as this. And this extends to the names of attributes, relations, aliases, so on. Everything is case insensitive. The only thing where SQL does make a distinction is there's a difference between what goes on inside quotes. So for an example, this is different from this, is different from this, and so on. So let's start querying this table further. So before, if we wanted to query all of the attributes, we used this star operator. Does anybody have an idea how could we do it if we only wanted to show the first name and last name columns? Does anyone have an idea? Yes? Yes, exactly. So we would do it like this. And this projects these two columns. And yeah, exactly. Does anybody know what would happen if we did, for an example, first name, last name, last name? Do you guys think this query would run or not? Anyone want to take a guess? Yeah? Actually, it does work. So you can, in that sense, duplicate columns when you run queries. And an explanation for why this would work is, for an example, if you wanted to select, let's say, first name, last name from employees, and you wanted to, let's say, union it with, let's say, another first name, last name, like username from some different database. Let's say it's called the client's database. So what happens is you cannot union if you don't have the same columns, or you don't have the same number of columns. I think also if the columns aren't the same name. But what you could theoretically then do is what we said here is, for an example, let's just say that the last name, we'd use it for the username, and we could alias it and rename it. We'll look at that later, and then this query would work. And so that's kind of a reason as to why, I guess, it would work. So one other thing that we can do, what do you guys think would happen if we were to run this query? Anyone have an idea? Yes. Yeah, exactly. And so for every first name and last name that we have these columns, and so we can basically have a constant that we add in the select statement. And notice that the name of this column is unknown. And so this is actually something that a syntax you're going to find in the exercises. So it'd be good to go over it. So what we could do for an example is rename columns. So this column is exactly the same as this column, except it's been renamed to number 1 and number 2 with this as operator in the select statement. So another thing that we can do is we can use arithmetic expressions in SQL. So notice that this column is no longer called emp number, employee number. It's basically unknown because we've done something on it, and obviously what we've done has worked. Yeah. So another thing that I showed you guys before, but it is possible. It is possible for you to select columns several times and use the same name. So if we were to do something like this and use this arithmetic computation, we would get a column, and we would have different values of this column. And so if we were to even rename this column and say and rename it to an attribute, do you think that this would, quote, be a violation of primary key constraints, since we now have employee number and we have non-unique values in this column? Anyone? Okay, so it's just important to know that this relation is not the employee's relation, and it is not something like just selecting the employee relation. Or it is not part of the employee relation, but it is simply a relation that's outputted or produced by this query, so it's something very different, just in case you guys get confused by something like that. So this is actually an opportunity to talk about how SQL runs on bags and does not run on sets. So if we wanted SQL to mimic running on sets, does anybody know how we could remove duplicates from a column? Yes. Exactly. So if we do something like this, we get exactly what we discussed, and it gives us the set semantics just like in relational algebra. So I want to quickly talk about union and duplicates in union. So if we were to union this query with itself. So we're going to union this column and union it with the exact same column. Does anybody know what happens? Will the query remove the duplicates, or will it keep all of the values? Does anyone have any idea? So, union, intersect, and except, those are all keywords where they will remove the duplicates, and bags are in that sense converted to sets. Does anybody know a keyword that we could use if we did not want to remove any of the duplicates? Yes? Exactly. So, sorry. Actually, I made a mistake. I'm sorry for that, guys. I accidentally added the keyword distinct. There. So now we should be getting all of the values in both these two. If you can see here, I also, if we were to have put this select distinct, we would have had the outputs 0 and 1, and so when you union all on 0, 1, 0, 1, then you get these 4 values, and if you were to union this column with itself, then you would get all 10 values. So it's the same thing with the keywords intersect all and except all. So let's look at some string functions, or some functions that we can use in our queries. So for an example, we can do something like this. Can anybody describe what this query will produce? Yes? Exactly. So this is the string concatenation operator. And these are all, I guess, more specific functions that I would say you wouldn't need to know by heart, but it's something that you could look up whenever you'd need to use it. And I guess it's just nice to know that there are functions like this and operators like this that do exist if you were to ever need them. There is something that is kind of interesting. Does anybody know what this would produce? Remember, birth date has a type date, which is a type in SQL. And so if we were to add 5 to the date, what would happen? Yes? Exactly. So you can see all of the birth dates have been added by 5. If we were to do this, anyone has an idea what would happen? Yes? Exactly. So this is just to show that there are a lot of there's a lot of like functionality. Oh, one thing I guess we could look through. We've looked here at dates and string. We can kind of, let's say, if we were to use this function Does anybody have any idea what this function might produce? This age function. Really? No one has an idea? Well, it does produce the age of each of the person based on what their birthday is. Yeah. Another thing that you could do is to extract year from age. And so now it's computed the age in days, and we've extracted what or how old this person is in years from how old or how many days they're alive. So yeah, we can see. And also, all of these columns, so for an example, when we've used the age function, it's been named age. When we've used the extract function, it's been used extract. So when, for an example, you use aggregations like sum or count, then most of the time these columns are renamed. But if you just use them the way that we have with like arithmetic operators and stuff, then typically the columns are not renamed and you have to use aliasing. Yes?
So this age function is just a basic built-in function of SQL.
Yes.
You can calculate an age from a date, that's a built-in function.
Yes.
Okay.
Exactly. All of these are built-in functions, and so I guess the point was to show you guys that there is and there are a lot of functions for dates, ages, strings, and you can look them up when you need them because they probably will exist. And yeah, I do think that some of these functions do come into the exercises. So if you ever see it and you're confused as to what it is, then look it up and you'll have a better idea. So I wanted to go back to our discussion on duplicates. So if I were to insert a sixth person, put the empty string, and I'll put myself.
There is a question on Zoom. There is a question on Zoom. I did the age computation query, and for me the values return as years are floating point values, and the attribute is named date part. Why is it different? So can it be?
Yeah, probably different version of Postgres SQL, right? So, yeah, I mean, I would say that.
Yeah, I guess based on your installation or how your computer runs. Okay, so back to what I was talking. Oh, sorry, I forgot. I already have someone. If I were to add some duplicate values, or what might look like duplicate values. So if I look at my table, we see that the name Shaban appears many times. Does anybody have an idea why it doesn't remove these duplicates of the word Shaban or the last name Shaban? Yes?
Because it's just a view. It's not like the relation itself, but also maybe it's the primary key is
yes, but if we were, for an example, to do this. Oh, sorry, my question should have come, I should have written the word distinct. Okay, same table that comes out, and I've used the word distinct, but I still have multiple values or multiple last names called Shaban. Yeah? Exactly. So it's important to remember that the entire tuple needs to be unique, right? And so if I were to, for an example, insert into employees values, obviously I need to change the primary key constraint to 9. But if I were to enter this tuple, then if I were to select distinct, Hans would only appear one time. So the entire tuple needs to be unique. And so just as I would, for an example, just query the last name, right? If I were to do distinct on the last name, does anybody have any idea how many tuples will end up after this query? Yes? Exactly. And so, yeah, I think that's important that you guys know that the entire tuple needs to be unique, and it's not just about duplicates within one column. One thing that comes up in the exercises is looking at, for an example, where clauses and when not to use where clauses, where equal and where in. So I'll do this quickly as an example. So if we were to query does anybody know, should we put here equal to or in? Does somebody know the difference, or would anyone like to explain the difference? So the answer here would be equal. I'll just quickly check. I actually don't think we have an employee number with number 2. I think we have one with 3, though. No, we don't have an employee number. Let me just quickly check. We also don't have an employee number with number 3. So so this was a mistake, but note that when we get no tuples, we can still use equal, and equal will run. When we have exactly, oh God, sorry, we also don't have 43. We will get the exact one tuple. So when you have a unary relation, you can use the equal, and when it's null, then obviously that still works for the equal. But if we were to, for an example, want to get many tuples, so more something like this. Does anybody have an idea? Oh, sorry, I queried too early. Does anybody have an idea as to what will happen? I've kind of given it away. Well, it will not work because there are equal will only work if you have one relation given back versus the way to make this query work is to use a keyword called in. And then it would work. And so it's really important to know or to remember that the where equals operator, it works when you receive a unary tuple or no relation, and the where in operator requires the subquery to return, or you can return multiple values. Yes?
The first where query you ran, is there a practical reason to do it like that, or could you just write where employee number equals to 4 without the brackets following that?
No, there is a reason. Why don't we try and see what happens when we remove these brackets?
No, I don't like the whole content of the brackets, just straight 4 or
Wait, so you're saying you want to remove what?
the entire statement after the equal statement and just put 4 there. Like everything to employees where employee
Yeah,
equals to 4.
for sure that would work. But if we were to look at these nested subqueries, and we were to, in that sense, still query something, then yeah, it would definitely be possible, right?
For the equality query, it was just syntactic sugar.
Yes, exactly. But if we were to, for an example, if we were to use the in operator for one value, because before I said that we use where is equal when the internal or when the nested subquery returns a unary operation, and we use where in when the nested subquery returns multiple relations. Does anybody know what happens when we do where in and it only returns one operation? Because we know for a fact that there only exists one employee that has 4. So we know for sure it'll return a unary operation, unary relation. Does anyone have any guesses or any ideas? Still works. So if you want to use the equal operator, you should know for sure that it's only going to return one relation, and in works any other time. Does anybody have an idea what happens if we were to do something like this? So instead of just querying for the employee number, we query for all the attributes. Does anyone know what will happen? So it's not going to work because there are too many columns. So in summary, it's important to remember that if you want to use in, it has to return exactly the column that you want it to return. Exactly. So we'll take a break now and meet back at 9:20. Thank you. So, can everybody hear me? Cool. So, let's start again. So, we've now looked at the difference between where in and where equals. And now what we want to do is we want to start using different tables and relations to make queries more, or what we can see how we can query with different tables and different commands and etc. So we're going to create a table called departments. We're going to have a department number that's an int, not null. We're going to have a department name that is going to be a char of up to length 40. We're going to name our primary key as the department number. So now when we use the command that I showed you guys before, we see that we have two tables. So now we want to insert values, or we want to insert tuples into the table. So let's first start with inserting in the same syntax that we used before. So our first department is going to be sales. Our second department is going to be marketing, or no, human resources. Another way that we can insert is, for an example, by doing first department name. Let's change this. So, right, we had first queried it. The way we created it was first department number, then department name, but with this like specification, like syntax, we can then switch it around. So it shows you that it's like you really can insert things however you want as long as you declare it. And we're going to then insert into another thing that we can do is, for an example, insert a tuple, and then insert another tuple immediately afterwards. Sorry, this should be number 4, so we don't violate primary key constraint. This should be 5. So, do you guys think this query will run? Anyone? Well, it will. So that's another way that you guys can insert tuples. You can see it's inserted 2 tuples at the same time. And the final example I'll give you is we can also insert using a select statement. So for an example, let's do tech department. This select statement, it's going to generate a new row. And so you can see that all of these ways that we insert tuples, they're all equal. And it doesn't really matter how you do it, but it's, I guess, nice to see all of the different ways that you can insert things and see how flexible it is. So now what we want to do is we're going to create a table called department employee, and this table is going to connect our employee table and our department table. So a department employee has an employee number, int, that is not a null, a department number, also an int, that is not a null, a from date, so when they started working at that department, a to date, and a primary key that is the employee number, the department number, and the from date. So these parts of these attributes, these are the ones where they must be unique. Again, you can have employee number is 1, but department number is 2, from date is 3, and then you could also still have 1, 2, and 4, and those would still be unique. So it's tuple-based. So we've now created this table, and it's joined us in our list of tables. And so now what we want to do is we want to create a query that says that every employee that we have in our employee table currently works in development. Does anybody know how you would construct such a query? Anyone at all? Is that a hand? No. Okay, so one way that we would do it is we would, actually, let me just quickly turn, do not disturb, sorry. What we'll do is we will do select employee number, 5 as department number, we'll do as from date and now as to date from employees. So this basically creates a table, right, with from our employee table, which is this one. It creates a table and it takes the employee number. It it has this 5 as a constant, and it aliases it to department number. So that's important to note that this department number is something that it was not taken from the employees relation, but it was something that we then created and then aliased. And we've then given all of them, and we've said that they've all started working in this department number 5, which I believe is, yes, development. And they've all been working up until now. And so this function now, it's like now. So it gives us now. Yeah. So basically, with this query, we've given us potential content for this relation that we just created, which is called department employee. Oh, sorry, guys. So we just started, this content, it has the exact same 4 columns, and we've just produced it, and we've decided on this content. We've said, okay, all of these employees, they've been working in development. They were hired on this date, and they're all working up until now. And so what we can do is then we can insert it into the relation. And we then just copy and paste exactly what we had queried before. And so this gives us exactly what we had queried, and it's now inserted it into our table. So this is one way for you guys if you want to, if you create a new table and you want to then take maybe different, or you want to add new columns or take different content from different tables, you put them in the select statements, you alias them, and then you can insert them into your new table. So what are things that could go wrong? We also looked at this before. Does anyone have any idea what type of constraint we might violate? if we were to do the exact same thing, we have primary key constraint. So it's the exact same concept, and here the primary key involves 3 attributes. So just as I mentioned before, changing one of the attributes or one of the primary key's attributes is enough. So for an example, if we were to take this and change it to the 2nd of February, right? Will this query work or will it produce an error? So we've changed one of the primary key constraints values, and we're trying to insert it into the relation. Yes? Exactly. So if we now query, it has all of the relations, including the new relations that we've just inserted. So one thing that works is, let's say we want to insert into department employee values, or I'll just do this here, 1, 7, 19, 18, okay. So, does anybody have any idea as to if this query will run or not? So, we are referencing a department number that does not, we haven't actually included into the departments table. And so we're now saying that we're inserting into our department employee table a department number that doesn't exist yet. Does that work? Does anyone, yes? Yes, but this, we do not use foreign keys, or we haven't declared any foreign keys. And so it does work as of, like right now, we were able to insert this relation, but please note that when in the lecture, when you guys do start to learn about foreign keys, there are more constraints, and something like this is not always possible. So another thing that I'd like to look at is the limits function. So what happens when I run this query? Does anyone have an idea? Yes? Exactly. So you can use this limit operator in order to limit how many rows that you want to have in the table. So now we're going to start looking at joins. So remember, department employee stores the relationship between an employees table and the department table. So if we quickly just take a look at the employee table, the department table, and the department employee table. It contains the department number connected to the departments table, and it contains the employee number connected to the employee table, right? And so when we want to connect tables, what happens if we do something like this. Does anyone have any idea? So what's going to happen is our output is going to be the Cartesian product of these schemas and the relations within the schemas. And does anyone have any idea how many number of rows that we're going to have when this query outputs? Yes? Oh, sorry, the number of columns was my question. Does anyone know the number of columns? But yes, you're right, for the rows, it's definitely going to be the number of each, of how many relations in each table. So the number of rows that we're going to have is 6 plus 2 plus 4, which is 12. And so the Cartesian product will output all of the number of columns that we're going to have is going to be 12, and the Cartesian product does output all of the columns in all of the tables, even the ones that are duplicated. So when we run this query, as you can see, let me just zoom out quickly. We have all 12 columns, and here our department number. We have employee number, department number from the department employee table, and it's the same department number in this department's table, and it's the same employee number. However, because we've done a Cartesian product, we haven't specified a condition where we want the employee number to be the exact same in both rows. Same thing with department number. We haven't specified equality. So it really just multiplies all of the tuples and the relations in all of the tables with each other. And so does anybody have any idea what we could do if we wanted to make sure that when we output these connector tables, that we specify that the employee numbers in the employees table and in the department employee table should be the same, and that the department number in the departments table and the department employee table should be the same? Does anyone know? Anyone have any idea? Yes? Exactly. I think my computer is having a moment because because this query was really large. Just hang on as we experience technical difficulties. Does anyone have any idea how to get Q? I did try, and now it's working. Cool, thank you. Q was the answer. Cool. Yeah, it's big enough. So what we can do is, just as someone in the audience said, is we can Cartesian product all of the schemas, and then we specify a condition where the employees employee number has to equal the department employees employee number, and the department number has to equal the department employees department number. So do you guys think this query will run? It will. And now we can see that the employee numbers in this column match the employee numbers in this column, and the department number in this column matches the department number in this column. And so one thing that is really important to mention as we continue with joins is there are so many different types of joins: inner joins, outer joins, cross joins, natural joins, full joins, all types of different joins. And one thing that kind of really distinguishes all of them is the number of columns that you have in each join. So for an example, this could be a question that would come up is when you output, or when, for an example, how many columns, what will your query or what will your table look like after you output this? And so when you use a where statement, it's really important that you remember that what you're doing is you're taking a Cartesian product of the tables and of the relations in these tables, and then you're taking a subset of them. So you still have the exact same schema, or you still have the exact same 12 columns that you would have had, I guess. Yeah, you can still see them. You still have the exact same columns that you would have had if you had just done the Cartesian product. Before we continue on to joins, one thing that is a cool trick for you guys is it's a lot easier to use aliasing in these situations. So for an example, if you say employees as E, departments as D, and department employee as DE, when you then use, or when you use the where condition, then you can just immediately just say E point employee number is equal to DE dot employee number. So it just makes it a lot easier when you use aliasing. Also in the select statements, you can also, select E dot employee number. So as soon as you alias it in these from statements, then you can, in your dot notation, when you're referencing the column of that table or of that schema, you're able to immediately use this dot notation. So then you can simply do D dot department number is equal to DE dot department number. And it outputs the exact same thing, and obviously none of the table's names have changed, because what we've done is we've aliased the name of the table relations, just so that we can quickly access them as we're typing and as we're querying and as we're setting all of the conditions that we're trying. So one thing that is also important to note is what happens if we were to do something like this. Does anyone have any idea? Is there anything that looks strange about this query to you? We are asking to project the columns employee number, the column first name, the column last name, the column department number, and the column department name. Hint, hint, duplicate columns. Is that a problem? Yes? Exactly. So that's correct. The database system doesn't know, should it reference this employee number or should it reference this department number? And yes, in this situation, they are equal, but not necessarily. We could very easily remove this statement, and then it would still be, all of them would be different, just as we had done before. And so it's important to know that you cannot exactly. The reference to employee number is ambiguous, and so when you want to specify, you should specify exactly which columns you want to access. So what you would do is exactly as I told, is exactly as I told you before. So you would do E dot employee number, E dot first name, E dot last name, D dot department number, D dot department name, DE dot two dot, etc. And then you would be able to write this query, and then it accesses exactly those columns from which table you specified. So this dot notation is important. So yes, we are now going to execute this query. I'll just copy paste it, maybe it's a bit easier. So this query, it selects all of these attributes to project, and it takes a Cartesian product of employees, of departments, of department employees, and it also puts this condition where we only want the employee numbers and department numbers that are the same, and it basically wants to project, or it wants to output the employees that are currently still working, or currently working with us. And so one way that we can express this is with these where. With the where condition. Another way that we can express this is, for an example, let's see. I don't know why it didn't output any columns. Let's try. Oh, wait, this is annoying. Okay. Let's see. Bigger equal? No. Maybe what about to date bigger than, I don't know, 2021, 1st of January. So we want all of like the hires that are still working up until now. What did I do wrong? Yeah, maybe. But actually, I don't know if you can compare date types, but it actually doesn't really matter. Anyways, we have queried, we want to find all employees that are now working currently. And so we've used it with the where statements. Does anybody know how to do it with join variants? So one thing that we can do is use something called a cross join. Does anybody know what a cross join is? Anyone? Cross join? A cross join just makes the Cartesian product explicit. So let me just quickly check and see. Oh, sorry. It shouldn't be, the bracket shouldn't be. I think you're, yeah, this one, right? I think that's, okay, you're right. Let's see. Sorry, guys. Okay, now we have an answer. But basically, the cross join is the exact same concept where you can, basically it just makes it explicit. And that's just pretty much it. You can just cross-join, and it outputs the exact same thing as the Cartesian product. Does anybody have any idea how many columns are going to come out of a cross-join, or how many columns we're going to have? Anyone? Actually, that's a stupid question to ask since I've already mentioned the columns. But it should be the exact same as a Cartesian product, because the cross-join is just syntactic or semantic sugar for, or syntactic sugar for cross product. So instead of using where clauses, instead of like performing this Cartesian product and then taking a subset, what is another way that we can do it? Does anyone have any idea? So one way that we're able to do this is use something called a natural join. So a natural join joins on the attributes that are in common on both sides. So we have employees, natural join, department employees. It'll join. It'll recognize that the employee table has employee number and that the department employee has also employee number, and then it'll recognize that those are referring to the same like values, and it'll make sure that they're equal, and it does the exact same thing with department employee to department. So if we query this, it comes out exactly the same. Yeah. So what happens to the columns if we take away aliasing and project everything? So we had done that before with the Cartesian product, and we had gotten 12 columns. What happens if we do the same thing with the natural join? So that would be select star from employees as E, natural join. Yes, we don't even need to alias it in this situation. We natural join it to departments. Then we natural join that to department employee. Will the duplicate columns disappear? Or will they stay the same? Yes? Ah, thank you. So do you guys think that, so you think that they're going to disappear? Well, they actually do not disappear. So that is something to note. And in practice, natural join isn't really the best join variant to use, because it doesn't always work, because all of the names always have to match. So in the sense that if, for an example, development, like in a company or whatever, were to add birthday to department, the birth date in department has the same name as birth date in the employees, and so then the values of those two columns must also match, and then our query outputs something that is completely different than what we intended and is meaningless. So it's the same thing with the entry specification. It's not always the best idea to use the natural join. So one variant that we can use is something called inner join. The inner join is, or it's called join. You can use either one. So you use this operator, join this department on, and then you specify the condition on which equality should hold. And it does the exact same thing. And just as I said before, inner join is also, I guess, the same way you could write join. So if we were to write quickly inner here, it would output the exact same thing. So you can use either inner join or join. Does anybody have any idea what happens if we project everything and we just join? Ooh, sorry. Anyone have any idea? Missing. Okay, this is weird. I'll just quickly copy, since we don't really have time to figure it out. Oh, God. Okay, I'm just gonna, cool. So, when we use the inner join, it's the same thing. The columns are still duplicated. I wonder if it's different if we just use join. Why don't we see? No, it's exactly the same. So one other way that we can also use join is with this semantics join using, and then we write the attribute that we are trying to join. And so this for an example would be the exact same thing. This join using, I guess what's nice about it, using this join instead of the cross product, it separates the conditions that are in the join or joining conditions versus other conditions like this where we're trying to query. Join using is syntactic sugar for join on. So you can also do the same thing where in one you use join on and one you use join using, and it's exactly the same. It's not exactly equivalent based on what columns are projected, in the sense that if we were to execute this query versus a query where we do just join on, it doesn't, you can see that they're out of order and that they're not necessarily the same. But semantically, it's equivalent. So it can be classified under syntactic sugar. I guess we have 2 more minutes. One thing that I'll just show you guys quickly is we looked at creating tables, right? And inserting tuples into tables, etc. But what happens if you want to change the actual table and not the relation in the table? Then you can alter the table. If you do it like this, it doesn't work. Oh, sorry. Alter table employees, add salary in null. So you'd have to add, you say which table you want to add to and what the name of the attribute is and what what the type is, and if it should be null and not null. If you do this, it won't work because, oh, it does work. Sorry. Oh, yay, okay, that's cool, it works. So now if we look at the select employees table, we can see that we now have inserted salary. And if you want to drop something, or if you want to drop like an attribute or drop a column, it's the exact same concept. And there you go. And the final thing that you can do is drop a table. That means just fully deleting a table. That's the syntax you use. And so if I were to now try and access it, it doesn't work. Cool. Class is over. Thank you guys so much for listening and for your patience. I hope you guys learned something. And if you have any questions, please don't hesitate to email us or to post in the forum, and we will get back to you. Thank you.